All right. Well, welcome everybody to Unit 4, Lesson 3, Solving Systems of Equations by Elimination. So this is what we are calling the third method. Method 3 is solving systems. We're talking about linear equations, systems of linear equations by elimination. So the word elimination means to get rid of, and so we're going to be getting rid of an x or a y. We're going to be eliminating a variable, a variable. Typically our variables are x or y, but they can be other letters besides that. Your objective is to solve a system of linear equations by the elimination method, but you will also have to manipulate the equations as necessary to eliminate a variable. We're going to focus in elimination. You can subtract, but it gets a little confusing. So we're going to focus on eliminating a variable, and we're going to press ourselves to do addition. Additive inverses are what they were called. Additive inverses. When you additive inverses like positive 6 plus negative 6, they always result in a 0. So we're going to learn this method using these 4 steps, but I'm going to actually add a step 5. So let's add step 5. Okay, and we have an essential question here. What are the 3 methods of solving a system of equations? Well, we have method number 1 was graphing. And what kind of equation do you graph with? We put it in slope, intercept form of a line. So we have the slope, we have the y-intercept, and then we graph it. 2, we had substitution. To apply substitution, you have to isolate a variable and then substitute. For 3, this is our new one, elimination. You have to manipulate the equations. You eliminate a variable. Eliminate a variable x or y. So that's the goal. It has 3 steps. Sometimes you're not going to have to apply step 1. You only apply step 1 if you look at your coefficients for x and for y and think to yourself, if I add these equations together, am I going to get an additive inverse that results in 0? So let's look at step 1. It says multiply if necessary. One or both equations by a constant. That's another big vocabulary word. So you're going to be multiplying one or both equations by a constant. When they say that, we're going to be talking about an integer. So at least one pair of like terms has the same or opposite coefficients. Now we're not going to subtract, so we don't want the like terms to have the same coefficient. We want to cross that out. We're just going to, so at least one pair of like terms has the opposite coefficients. If they're opposite numbers and we add them together, we'll get 0. So then you proceed through the rest of the steps. Step 2, add or subtract. Well, we're not going to subtract, so we're just going to add. Cross off or subtract, and just write add the equations to eliminate one of the variables. Solve the resulting equation for the remaining variable. Then once you know an x or a y, you can plug it into one of the other equations and solve for the one you don't know. Step 5 is to write your solution as an ordered pair. X, comma, y. You always finish with writing as an ordered pair. Anytime you need to capture this, go ahead and capture it with your as needed. Let's look at the first example. In the first example, we don't have to apply step 1. So what we do first is we go to look at the equation. We have equation 1 and 2. I'm going to make this a little bigger. And then we look at the coefficients. This has a coefficient of 1 and 1. If I add these together, I'm going to get 2x. That doesn't eliminate anything. But look at the second pair. The coefficient for the variable term of y. Plus 3y minus 3y. That will, if I add them together, result in 0y. That's my goal, so I don't have to manipulate the equations. Let's see what happens when I do add the equations together. I'm going to write a little plus sign right there because I'm adding them. X plus x is 2x. 3y plus negative 3y is 0y, so that's the reason it just goes away. You've eliminated y. You only have x. Now you're solving a really simple problem. On the right side, negative 2 plus 16 leaves you with 14. You can apply mental math. You know 2 times what is 14. You get your answer is x equals 7. Now, you found x. Go back and pick either equation. So either equation 1 or 2. In this case, in this example, they picked equation 1. Equation 1 is x plus 3y equals negative 2, so they're substituting into the equation 1 for x. And they get 7 plus 3y equals negative 2. Inverse operations means you subtract 7 from both sides, and you get 3y equals negative 9. Divide by 3 and y equals negative 3. So they've got x and they found y, and then the final step, write your answer as an ordered pair. Okay, I have somebody who asked if I could push back so you can see a screenshot. I'm going to do that now. You can always take a screenshot during the lesson. So again, elimination method, step 1. This is what we're going to have to apply on the next example. Because if you add the equations, they won't result in 0. You have to manipulate them. So here we have method 3, elimination. After you manipulate them, we're gonna add them together, and one of the variables is going to disappear. So here we go. We have negative 6x plus 5y equals 25 and negative 2x minus 4y equals 14. So if you look at this equation here, equation 1 and equation 2, if I add them together, I'm only going to add, remember? If I added that, I'd have negative 8x. That doesn't eliminate. And here I get 1y. That won't eliminate, and I'd have 39. So that's no good. I have to make additive inverses. So I need negative 6x. I can multiply by negative 3 to get positive 6x. See, they're going to subtract, but we're going to not subtract. We're going to just do adding. So let's multiply instead of by 3. I'm going to cross that off, and I'm going to multiply by negative 3. Nothing changed in the top equation. In the bottom equation, I'm going to multiply everything times negative 3. So I get positive 6x plus 12y negative 42. I do that so I can add the equations together. It's easier to add. So here's our revised equation. I'm not going to subtract. I'm going to add. What did I have up here? Positive 6x, positive 12, and negative 42. So now I'm just adding. Notice that negative 6x plus 6x is 0. 5y plus 12y is 17y. 25 minus 42 is negative 17. If I divide by 17 both sides, I get y equals negative 1. And then they picked equation 2 to substitute in. Way up here, equation 2, which is negative 2x minus 4y equals 14. Now they know the value of y, so you can substitute it in. Negative 2x minus 4 times negative 1 is positive 4. Subtract 4 from both sides, and you get negative 2x equals 10. Divide by negative 2, you get x equals negative 5. Almost done. Your final answer is negative 5. That's your x value, comma, negative 1. If you screenshot, go ahead and take a quick one. We'll do some simple examples. We'll go from simpler to more difficult. Let's take a look at the first one. Remember, step 1 is to check to make sure if you add these equations together, are you going to eliminate a variable? Are you going to get a 0? So you don't need to do step 1 here, because I already have equation 1 and equation 2. I just need to add them together. Negative 5x plus 5x is 0. 2y plus 1y is 3y. 13 plus negative 1 is 12. So if I divide by 3, I get y equals 4. So since I know y equals 4, I could pick either equation. Let's just pick equation 1. I don't think there's a big difference on this problem. Negative 5x plus 2, but I know y now. It's 4. Negative 5x plus 8 equals 13. I'm going to subtract 8. That goes away. I have negative 5x equals 5. If I divide by negative 5, I get x equals negative 1. I'm almost done. Remember to give your final solution as an ordered pair. Negative 1, comma, 4. I can check that answer mentally here. Negative 1, if I put negative 1 in for x, I'd have negative 5 times negative 1 is 5. Plus 2, that's positive 5. And 2 times 4 is 8. So 5 plus 8 is 13. That's a check. And then if I put negative 1 in here, I get negative 5 plus 4 equals negative 1. Negative 1 equals negative 1. Check, check. So I did that one right. Okay, now let's take a look at our situation on this problem. Here's equation 1 and equation 2. The first thing I need to look at is my variable terms. I can only add like terms. So note, you can only add like terms. Now if we look here, negative 5x minus 3y, those are not alike. The 2x is here. So I can apply the commutative property. Which means I can write these in a different order on the left-hand side. The positive 2x can be written first and then minus 3y. So I'm going to rewrite this. Align like terms vertically. So I'm going to not change equation 1. 5x plus 2y, that's negative 5x, equals 9. Now I need to write the variable term with x first. Positive 2x, and that term is minus 3y equals negative 19. So now they're aligned. I want to add them together, but if I add these two equations together, that's not going to eliminate x or y. I'm going to get negative 3x here. I'm going to get negative y here if I add these together. So I have to manipulate under step 1. And the way you're going to do that is you're going to draw a line going from left to right. And then you're going to multiply by something that's going to make them the same least common multiple, we call it, because you want them to be opposite. So the first number, the multiple that negative 5 and 2 get to is 10. So I want to multiply the top equation times 2, and I'll multiply the bottom equation times 5. Notice they're both positive numbers because I want the signs to be different so I can add them together. So I didn't change any of the signs. What the result is, negative 10x plus 4y equals 18. And this one I'm multiplying by 5. 10x minus 15y equals, that's a big number. 50 and 45 is negative 95. Now I can add them together. I get 0x (4y) plus negative 15y is negative 11y. Ooh, here's a hard subtraction. Let's see, that would be 85, 78. That's negative 78. Do my calculator real quick. $77. I knew I was off by something. Negative 77. So I'm going to divide by negative 11, and I get y, I ran out of space, y equals positive 7. And I can just pick one of the equations to solve for y. Let's do the second one. 2x minus 3 times 7 equals negative 19. That's 2x minus 21 equals negative 19. I'm going to add 21 to both sides. And I get 2x equals 2, so x equals 1. And my final answer has to be an ordered pair. The final answer is 1, 7. And if you plug them back in there, they should work out. Negative 5 plus 14, that's right. And make sure that's negative 21 plus 2. Yes, they both check. Check, check. Now we have a little harder example. This one we're going to deal with some fractions. And as an 8th grader, that's what you need to do, is to be able to deal with fractions. So I need to manipulate these equations. I can eliminate y by multiplying the second equation by 2. Then I'd have 4y minus 4y. Or I can multiply times the bottom equation by negative 2 and eliminate x. I'm going to eliminate y. I'm not going to change anything in this equation. So I'm going to multiply times 1. But the second equation, I want the signs to be opposite. I'm going to multiply times 2. So I end up with 10x plus 4y equals negative 2. Now I'm multiplying by 2. 10x minus 4y equals 4. I'm going to add these equations together. I get 20x, and that's gone. Negative, I'm adding. Negative 2 plus 4 is 2. And then I divide by 20. And x equals 1 over 10. So you're dealing, as an 8th grader, with some rational numbers like fractions and decimals. But let's not put it in a decimal. Let's keep it as a fraction. Now I have x. So maybe I can use this equation because it looks pretty easy. If I substitute 1/10 and multiply times 10, that'll be easier to work with. So let's use equation 1. Sorry, let me label it equation 1, equation 2. So we have 10 times x, which is 1 over 10, plus 4y equals negative 2. 10 times 1 over 10 is 10 over 10, or 1, plus 4y equals negative 2. Subtract 1. You get 4y equals negative 3. I'm going to finish it off over here. 4y equals negative 3. I'm going to divide by 4, and I get y equals negative 3/4, and I'm done. I circled both of my answers. I'm going to put 1 over 10 and negative 3/4. And that's the method of elimination, the third method. Again, it's not in your textbook, so these are your only notes and the supporting ed puzzles that go with them.